Good evening all. My name is Madhan Reddy. I am studying first year in JNTUA College of Engineering, Anantapuram. I am from EC department and this is my first YouTube video. And today I am going to discuss about a topic in C programming and data structures. In C programming and data structures, I am going to discuss about sorting. Coming to definition of sorting. Sorting is the process of arranging a list of elements in a particular order. Either it may be ascending order or descending order. For suppose, if we have given a list of random elements, by using this sorting technique, we can arrange those elements in either ascending order or descending order based on our priority. And now coming to types of sorting, mainly you have three types of sorting techniques are there. 1. Bubble sort, 2. Selection sort, and 3. Insertion sort. And now among three types of sorting techniques, that is bubble sorting, selection sorting and insertion sorting, in this video we are going to discuss about insertion sorting. Coming to its definition, insertion sort algorithm arranges a list of elements in a particular order. In insertion algorithm, every iteration moves an element from unsorted position to sorted position until all the elements are sorted in the list. And now in this slide we are going to discuss about algorithm of insertion sort briefly. So in our code we will run a loop starting index 1 till n minus 1, and first we will create to keep value. So temporarily we will keep a of I in this particular variable called temp. Here temp is used to keep value, and then I will take another variable to mark the position of the whole I. I is used to mark the position of the whole, and then we need to shift all the elements greater than the value to be inserted at right, while whole is greater than 0 and the element at index whole minus 1 is greater value, and we will shift whole minus 1 to the whole. So our new whole will be index whole minus 1. When we find a smaller element than value in the sorted subset, this particular condition will be false and we will exit the while loop when whole will be equal to 0. So there will be no more element to shift, and finally we will come out of the while loop. And before coming out of the while loop, we will put the value into the loop, and remaining is our pseudocode for insertion sort. And now here we are going to consider the following unsorted list of elements. Those are 15, 20, 10, 30, 50, 18, 5 and 45. And these are arranged in a random order without following any ascending or descending order. First of all, assume that sorted portion of the list empty. That means all the elements are in random order and all the elements in the list are unsorted portion of the list as shown in below. And the second picture show you the unsorted position of the list. Here none of the element is sorted. And at the top of the list we can see 15, and at the right side of the 15 we have 20 in the given list. Move the first element 15 from unsorted portion to sorted portion of the list. So to move element 20 from unsorted to sorted portion, compare 20 with its left side element 15 and insert it at correct position. So we have inserted 15 comes first and then 20, and next to 20 we have 10. To move element 10 from unsorted to sorted portion, compare 10 with its left side element, that is 20. And compare to 10, 20 is greater and 10 it is smaller. So swap. And then again compare 10 with its left side element 15. Again 15 is greater than 10. So swap this and insert 10 at its correct position in sorted portion of the list. After sorted portion, we have 10, 15, 20 and these three elements we have sorted. And next to 20 we have 30. And to move element from unsorted to sorted portion, compare 30 with 20, 15 and 10. Here we have left side of 30 we have 10, 15 and 20. And compared to 30, these all numbers are smaller. So 30 is directly inserted in sorted portion of the list. And after this sorted portion of the list, we came with 10, 15, 20 and 30. And these four elements are sorted. And we have unsorted elements 50, 80, 5 and 45. So right side of the 50, 30, we can observe 50. To move element 50 from unsorted to sorted portion, compare 50 with 30, 20, 15 and 10. Those are left side of 50. And compared to those 30, 20, 50 and 10, 50 it is larger than all these elements which are at left side. So 50 is directly inserted at last position in sorted portion of the list. After this sorting, we have 10, 15, 20, 30 and then 15 in sorted portion of the list, and we have remaining 18, 5 and 45 in unsorted portion of the list. So to move 18 from unsorted to sorted position, compare 18 with its leftmost elements. Those are 30, 20 and 50. Since 18 is larger than 15, move 20, 30 and 50 one position to the right in the last and insert 18 after 15 in the sorted position. And after this sorted position, we have 10, 15, 18, 20, 30 and 50 in sorted portion and 5 and 45 in the unsorted portion. And to move element 5 from unsorted to compare 5 with its leftmost elements. Those are 50, 30, 20, 18, 15 and 10. Since here 5 is smaller than all these elements which are at the left side of the 5. So move 10, 15, 18, 20, 30 and 50 one position to the right in the list and insert 5 at the first position in the sorted list, because here 5 is smaller than all the elements which are at the left side of the list. And after this sorting portion, we have 5, 10, 15, 18, 20, 30 and 50 in the sorted portion, and we have left with 45 in the unsorted list. So to move that unsorted element 45 from unsorted to sorted position, compare 45 which is with its leftmost elements 50, 30 and 18, 50, 10 and 5. Here 45 is larger than 30. So move 50 one position to the right in the list and insert 45 after 30 in the sorted list. And we have ready with all the sorted list. That is, we came with 5, 10, 15, 18, 20, 30, 45, 50. Here we have sorted all the elements in the ascending order, and we have no elements in unsorted position. Unsorted portion of the list has become empty. So we can stop the process, and the final sorted list of the elements is given in the last list, that is 5, 15, 10, 18, 20, and 50. And we have seen all this in the previous slide. And unsorted portion of the list has become empty at last. So we can stop the process, and the final sorted list of the elements we can see at the last of the slide. And now coming to C program to implement insertion sort. At first we declare header file has include stdio.h, and then we have written function declaration. We have declared all the returning values, and then we went for function definition, where we have written actual code to get sorted list of array elements. And then we came for main function. Here we have declared local variables. Those are size I, j, and a, which can of maximum size 100. And then we can read the size of the list and store that in the size variable size. And then we are going to read all the files which are going to sort. And after that, insertion sort a comma size, which is function call. Once the function call is read, the compiler goes from this function call to function definition, where actual code is written inside it, and the actual code get read, and we get actual elements after sorting, and again it comes to from function definition to function call, and then we print list after sorting, and that for loop we use to read the list of elements after sorting. And at last, if we follow the code which I have discussed above for the implementation of insertion sort, and at last we get output like this. First enter the size of the list. We are going to sort 5 elements which are in random order, and then enter 5 integer values. We have to enter 5 integer values which we are going to sort, and then we get final output. List after sorting is 10, 15, 20, 34, and 44. Here we have given random elements which are in which either follow any ascending or descending order. Those are 20, 15, 34, 10, and 44. And after that, at last we get list after sorting 10, 15, 20, 34, and 44. These are arranged in the ascending order. So that's it for insertion sort. Thank you all.